My name is Carlo Daffara. I'm CEO of NodeWeaver and the original architect of the platform. And I will try to introduce to my best why the edge is complex and why we can solve the problems of the edge. Uh, the edge, that is when you have to process data near where the data is produced or is consumed, is actually composed of a variety of different use cases and different requirements. Sometimes you have strong latency requirements, like in industrial automation or in high-speed packet processing. Sometimes you have bandwidth limits or completely disconnected systems. You have issues with physical security because some of these devices are in the open. Sometimes you have difficult environments, which may be a steel plant, but it may also be a fast food restaurant. Nearly always you have high availability requirements, which means that if something goes down, it's a mission critical appliance and you need to have it back as soon as possible. Sometimes you have very remote locations. Sometimes you have physical constraints. You may have no local IT capabilities. You may have hundreds or thousands of locations. And especially you have lots of different data regulations and data protection acts that you have to comply to, along with the internal security practices of your own company, which means that the edge is different. What works in a data center does not work here. And that's why we have worked to create NodeWeaver, which is a software layer that runs on bare metal, and it is designed to convert these hardware devices into what we call a nano cloud. Nano, because NodeWeaver is very thin, it's just over 1 GB of memory and takes less than a physical core. It does have the kind of capabilities that you would find in a public cloud. The ability to run virtual machines, Kubernetes application, auto-scaling, orchestration, high availability, real-time support, and the ability to connect to those nano clouds from anywhere in the world without needing need of any additional services support. But we strive for what is called autonomic management. We handle everything at the hardware layer so that you don't have to. No matter what hardware you want to use, and no matter what combination of hardware you want to use, because actually we support heterogeneous hardware devices. And we do support zero-touch installation, as we will see in a few minutes. As a software layer, it's a modular system. We do have our own software-defined storage, software-defined networking, virtual switches, orchestration, and we organize application in a structure that's called a marketplace. Basically, it's a structure, a logical structure that allows to package and distribute application so that they can be deployed with the one click anywhere in the world in any number. We support Kubernetes through our own implementation, which is CNCF compliant, but we support other external Kubernetes layer as well. We support integration with public cloud through Azure Arc and AWS SSM, which can be injected directly into the workload. And we run on nearly everything. We do have a few partners which we work already, like Intel, Lenovo, Supermicro, and many others, but we really run on anything which is x86 compatible. So we are able to, let's say, adapt to a variety of needs and situations. The key idea behind NodeWeaver is that we want to minimize the total cost of management and deployment and operation of an edge layer. We support any number of deployments. And the key idea is that we want to minimize the cost of managing from the beginning to the end, from day -1 when you procure the hardware to day n when you have to manage applications. So we do have let's say, our own approach to minimize the acquisition cost. Since the platform is so thin, you are not wasting hundreds of gigabytes for running a complex software layer. So you can buy exactly the hardware that you need for your workload. And you can mix and match the best devices for your needs. Deployment is incredibly easy. It's really zero touch. No need to prepare the hardware beforehand, no need to ship it to a central location. Deployment can be done without a monitoring keyboard by anyone, and especially reducing the management cost, because it's the most important, let's say, part of the longer lifetime of an edge. If we think that some of these devices go in the field for many years, management is really what makes the difference. The fact that the hardware layer is completely managed by the platform means that you don't have to care about exactly what goes in what disk or how you are allocating resources. And the fact that orchestration and remediation is part of the platform means that basically you just have to go and check every few months to see if everything works. We do have a variety of use cases. We do have customers in many verticals. One of this is energy. The top left image shows one of our deployments in Sub-Saharan Africa. This is a company that deploys mixed solar and wind farms in remote locations. Some are very remote, like 1 or 2 days of drive, which means that high availability is essential, because if something fails, you are not, let's say, it's not easy to send someone to repair it. And this is one of the cases where connectivity is also ephemeral. Basically, it's connected by satellite just once or twice per day. We do have a lot of industrial automation use cases, like, for example, detection of bad welds through deep learning. We do have a company that uses NodeWeaver to drive a high energy electron beam to create titanium protheses in the biomedical field. We do have companies that use NodeWeaver to drive packaging systems. We have many customers in the surveillance and the security area, both municipalities, law enforcement, and highly regulated areas like casinos. And one of our largest customer uses NodeWeaver as the basis for their NFV deployment. So they use NodeWeaver to do all the packet processing inside of ships. It's one of the largest cruise ship operator in the world. And basically, every packet that goes through a ship goes through NodeWeaver. And they employ a variety of workloads and a variety of software layers, from security, packet processing, traffic optimization for the satellite connection, and so on. So it's really a mission critical application. The key aspect we have focused on is in making sure that deploying NodeWeaver for the edge can solve all the problems that we have encountered over the years. So through zero-touch deployment, which can be done really by anyone, the ability to support air-gapped environments and environments where bandwidth is limited or is extremely costly, autonomous operation on every step of it, and we will see a demo of it later on. The fact that it's lightweight, we do have customers that run significant workloads in devices as small as a Raspberry device with 8 gigs of RAM. We do support deterministic performance, which means that we are able to provide strong guarantees that a workload will not be impacted by competing workload, including the ability to run real-time workloads. So we can provide a bounded latency for deterministic applications, and highly available and persistent storage, which is one of the key components, because many of our customers found that the edge creates a lot of data. We have customers that are generating terabytes of data per day, so storage is an essential component of that.
You mentioned that you run anywhere and everywhere. What does anywhere and everywhere really mean? What kind of devices? You said Raspberry Pis, for real?
Raspberry Pi class devices, so 1 or 2 cores system on chip from Intel. So we are talking about devices below $100. We do have a variety of customers running fanless systems. Again, in the 2 to 4 cores ones, so 20 to 40 watts maximum. We do have some customers running, let's say, larger devices. We have a customer that has in the telco space that uses NodeWeaver for delivering services, gaming services, and they have servers with half a terabyte of memory and 8 NVMe disks. So we go in, let's say, from very small to fairly large. I would say that the majority of our customers tend to deploy systems in the industrial fanless class or in the small, let's say, range. As in the where, really anywhere from plants, industrial plants, in external devices in Africa and Southeast Asia. We do have customers in Australia, Israel, well, Germany, France. We do have a lot of municipalities in rural areas across Europe. So I would say that we do have a wide range of environments.
If you like, we actually have here in the room, and we're going to be demonstrating this on a future segment. But in the room, we have some small devices that we're going to be installing on. This one happens to be a 2-core Intel Atom-based processor, but we're also going to be demonstrating on a variety of other systems, Intel Core-based, Xeon and Xeon D, traditional data center class servers. So really, as Carlo said, we'll run on anything, even very small devices, which is one of our differentiators.
I have a question regarding where you sit in the stack. So is NodeWeaver an operating system that sits on the hardware, or is it a virtual machine or a container that's running on an existing operating system? Like, where does it run in the stack?
It's an operating system, an application layer. So we run on bare metal, and every workload runs on top of NodeWeaver. We do have a variety of hypervisors that are automatically selected depending on the kind of workload that we do have. So we have what we call the legacy hypervisor, which is used for traditional, I don't know, Windows VMs or for workloads that have been ported from a physical layer. We do have a very thin hypervisor, which we call thin VM, which is designed to run Kubernetes apps and to run workloads that are modern, like last generation Linux machines.
Okay, and that operating system, is that Linux-based, or did you?
Yeah,
you write
it's an hardened Linux-based OS based on Alpine, on which basically it's just the booting layer. Everything else is done by us as modules that run on top.
Yeah, you said Alpine, so immediately I'm thinking, yeah, that you start with almost nothing. You build up from there.
That we built it from there. Yes.
Okay. And then to run containers, do you have a standard container runtime that you prefer, or is it up to the customer to select which runtime and other components they want to layer on top of the operating system?
We do have our own Kubernetes layer, which is part of our standard public marketplace, which is based on micro K8s. It's simply, let's say, a convenience, because we have found that many customers want to run a Kubernetes apps, but they don't have a preferred layer. They still are learning how to deploy it and so on. Mm-hmm. So we have made that as a choice because it's compliant, it's very complete, and we have extended that to support multi-master, auto-scaling, and so on. But we do have customers that, for example, prefer to run other things like OpenShift or Rancher. So the idea is that we provide a base layer that allows the customer to immediately start to use Kubernetes. And that's integrated tightly. So, for example, it uses our high availability mechanism, which is very fast. We use our storage layer to present the reliable storage to the containers. But if the customer wants to use their own layer, because, for example, they have standardized on that, they're absolutely free to.
Okay, thank you.
So if you're running directly on the hardware as an operating system, that means that there is an HCL, a hardware compatibility list? Because
No.
running on any hardware is a bold statement. So
Yeah, that's the thing is that having an ACL is something that we thought about, but we found it was very limiting for our customers, that they encounter an enormous variety of hardware devices. We do have customers that use custom spatial devices or appliances that are not, let's say, part of what you would consider a normal HCL. So we do have a basic layer that allows us to test the hardware. So the system immediately will tell you if it's possible to run NodeWeaver on and if we are able to take advantage of all the properties. If we found a device that we are not able to handle, we do receive a request, an automated request for a board support package. And basically, that is a small layer that just adds the compatibility layer for that specific device. However, the advantage of using, let's say, a modular system means that so far in the last 4 years, we only got one request to add a specialized deep learning device, which is something that we added in 48 hours.
Yeah, it's part of our overall philosophy that because of the vast diversity of systems that we see at the edge, given that some devices could be running in a metal box on a pole, and some could be running in a air-conditioned data center, we see a big diversity of the hardware that customers want to run on based on the environments that they're going to be deploying into. So it's part of our overall philosophy that we intentionally don't have a hardware compatibility list, and instead what we do is we qualify at the time the customer wants to deploy. So it's a kind of a big departure from the traditional philosophy about which hardware do you support. We support anything you want to support, and like Carlo said, we'll add support for it if we don't already have it.
Do you have to have the same nodes at each site as part of which forms the cluster? Do you have to have the same types of nodes, or can you mix and match?
No, you can mix and match, not just from different manufacturers, but totally different chipsets. So actually what Gina's going to do for us later is we're going to start with a first server that's Intel Core based, and then we're going to add a different server, different manufacturer, different chipset. So we can intermix Intel Atom, Intel Core, Xeon D, Xeon Scalable, different generations, all in the same cluster with no loss of functionality. And we'll explain later how we do that.
Great.
But absolutely, we can intermix.
Also AMD and Intel on the same.
Oh yeah, yeah.
Oh, AMD as well. Nice.
Supporting live migration between the two.
What about RISC-V? Any support for RISC-V yet?
Yeah.
Not yet, but it's on the roadmap. I confess I'm a big proponent of RISC-V. We tried to make NodeWeaver as much platform agnostic as possible. So, for example, we do have a beta for ARM, but we really believe that in a few years from now, RISC-V will become a real contender, especially because it's extremely flexible. And we expect a lot of new silicon to come out with specialized silicon for things like deep learning, for things like tensor processing, and so on. If you look at most of the new designs in the AI accelerator space are all based on RISC-V, and even NVIDIA inside of their chips, they do have a RISC-V component as well.